Okay. So this next lesson will be on the first and second derivative test. So we go and we think in terms of a graph, some kind of curve. So something that looks like that. And we look to see what's going on with this curve. We can see that over this region that it is increasing. From here to here, it is decreasing. And then over in this region, it is increasing again. At this point up here, if we were to take the derivative at that point, we'd find out at the very top it would be 0. And so this, at this point, would be a relative maximum. And down here at the bottom of this curve, again, at the very bottom of that curve, the derivative, the slope, at that point would also be 0, and this would be a relative minimum. So with derivatives, we can find out where the min and max are relative for our given curve. Right? Also, you notice in terms of this curve that it goes through a change in the type of curve. And so we can also find that out by doing derivatives. So this curve here, this piece, is what's known as concave down. And then this part here is concave up. And we can find that out where this point is, where it switches from our second derivative test. So today we'll be on first and second derivative test and what information that tells us in regards to our graph. So let's look at a few examples as to how this works. So for example, let's say we have this function, f of x equals 2x cubed plus 3x squared minus 6x. So first off, in terms of our first derivative test, now the first thing we have to do in our first derivative test is find the first derivative. So f prime of x, this will be 6x squared plus 6x, actually this should be a 36, minus 36. Okay. So the first step in the first derivative test is find the first derivative. So, step 1. Find first derivative, which we did. Step 2. Take the first derivative and set it equal 0. So step 2. Set first derivative equal 0. And after all, when we do that, we're looking to find those points where, on my curve, that we are either here or down there. That's why we set it to 0, because out of those points, the slope will be 0. Okay. So we set it equal to 0, and so step 3 is going to be to then solve for x. And so we're going to take that and solve for x. So if I look at this quadratic, first off, I notice in regards to the numbers that 6 goes in everything, so let's factor out a 6. That'll make this quadratic a little bit easier to deal with. So with that. Again, it's a quadratic, it's factorable. It's going to be an x and an x. It's a minus 6, so we know it's got to be a plus and a minus. And then we need two numbers, multiply together to give you 6, have a difference of 1, and so those will be 3 and 2. So we want to continue solving for x, and so we get x plus 3 could equal 0, or x minus 2 could equal 0. So here we'll subtract 3. So x could equal negative 3, and then here we will add 2, and x will be 2. So we found the values of when the slope will be 0. So now we can figure out in terms of this curve, really, where is it increasing, where is it decreasing. So to find out in regards to the slope. So now we basically built a number line. We put our two x values, negative 3 and 2. And then our factors from our derivative were x plus 3, x minus 2, and then we did have the 6. Right? And then we want to know, in terms of what's going on here, what is the value of my derivative? And so we need a little bit more room here. X equals 3 minus 3, x equals 2. So we're going to find out what is the sign of my derivative over these various intervals. So my first interval is x is less than negative 3. So if it helps, you can think of a number less than negative 3. So let's say negative 100. Well, if x is negative 100, this will be negative. X minus 2, that would also be negative. My 6 is always positive. And so a negative times a negative is a positive. And a positive times a positive would be a positive. We then go to the next interval between negative 3 and 2. And again, if it helps to pick a number, you can do that. And let's go with the easy number, which would be 0, which falls in that range. So x plus 3 would be positive. X minus 2 would be negative. Again, 6 is always positive. And so now we got a positive times a negative times a positive, which means that will be a negative. And then we get to our last interval, 2 and greater. And so if x is greater than 2, this is positive. X minus 2 is positive. The 6 is always positive. And then a positive times a positive times a positive will be a positive. So what this tells us then is that here my function is increasing. Here it's decreasing. And then here it's increasing. So we know a bit about what's going on with our graph and how this is working. We can also, because we know the x values here, we could go back to our original equation and find the corresponding y values. Right? So the original equation was that f of x was equal to 2x cubed, 3x squared, minus 36x. So we plug in our numbers then. We first plug in the negative 3, we get 2 times a negative 3 cubed, 3 times a negative 3 squared, minus 36 times a minus 3. Well, negative 3 cubed is a negative 27. Negative 3 squared is 9. And 36 times 3 will be actually a positive 108. So this will be a minus 54. This is 27. And this is 108. And so we put that all together, we end up at a 71. And that would be the corresponding y value that goes with that. We can also do the same thing with our 2. So with the 2, we get that f of x would equal 2 times 2 cubed, 3 times 2 squared minus 36 times 2. 2 cubed is 8, so 2 times 8. 2 squared is 4. That is 72. So 16 plus 12 minus 72. And so that'll get us to 28, that'll be 4, and that will be negative. Okay. So we got the x and y coordinates for in terms of our min and max, okay? So here my slope went from positive to negative, and so that means that negative 3 is a max. Okay? Here I went from negative to positive, which means the 2 is a min. And so again, this basically goes along with my graph I first drew. If you go from a positive slope to a negative slope, we're at a max. And if you go from a negative slope to a positive slope, you have reached a min. So we have this information in regards to our graph. And so basically with that information, we could get a rough idea of what's going on with my graph. Right? So just a quick graph of what we know here. And this won't be to scale, but let's put on here that this is negative 3. This is 2. Right? We said that the max occurred at 71 and then negative 44. So 71, so we're going to just say that's 71. And we'll say that this is negative 44. Okay? And again, it won't be the scale. But what do we know about our graph? Okay? We can also do something else really quick. And I can find the y-intercept really, really quick here. Because at the y-intercept, the x values are going to be 0. Okay? So I know that the y-intercept here, well, if this is all, if x is all zeros, the intercept is at the origin. So I also know that it cuts here. So we got this point, we got this point. We know from our derivative, we said that from negative infinity to 3, to the negative 3, it's increasing. So my graph is coming up like this. It's hitting this point. At that point, it curves and heads back down because here it's decreasing. It cuts through the origin, it hits this bottom point, and then it takes back off and goes like that. Right? So that's roughly what the graph will look like. Again, my axes are nowhere near the scale, but basically that's going to be the shape of what's going on with this particular graph. So we got here, again, waveling on the graph, we got here it was increasing, here it was decreasing, here it was increasing. We got the max here, which we said was at negative 3, 71 was that max point. We got our min, which we said was at 2 and negative 44. And we got everything in terms of our first and second derivative test, and what it tells us in terms of increasing, decreasing, max, min. Well, you can see in this graph that it goes through this change in the curve. Right? And that is what we learned in the second derivative test. So the second derivative test tells us an idea of the shape of the curve. So if it's like this, it's said to be concave up. And the second derivative will be positive. And then if it's like this, it is concave down. And the second derivative will be negative. So just remember, when you are doing your calculus work, just remember to turn your concave down upside down. So second derivative test, and what does it tell us? So first off, to do the second derivative test, we have to find the second derivative. So let's go back to our problem. And we found the first derivative, which we said was 6x squared plus 6x minus 36. So we had 6x squared plus 6x minus 36. So that was my first derivative. So now we want to find the second derivative. So all we do is take the derivative again. So this will be 12x plus 6. Right. So step one in the second derivative test is find the second derivative. So step one, find second derivative, which we just did. Step two, set it equal to 0. Equal to 0. And we'll do that. So we get 12x plus 6 equals 0. Step 3 is solve for x, and so we'll do that step. So step 3, so let's do that. So in this case, subtract 6, subtract 6. So we get 12x equals a minus 6, divide by 12. And we get x equals negative 1/2. And just like we did before, we're now going to set up a chart. And so we'll have here now on our chart, negative 1/2. We only have one term here. And again, we're going to say, okay, if x is a number less than negative 1/2, what is the value of 12x plus 6? So this would be negative. My second derivative is only that, so that'll be negative. If x is greater than negative 1/2, then this will be positive, and my derivative will be positive. And so this will be concave down. This is concave up. And this transition is called an inflection point. So that is the point where the curve goes from this shape to this shape. Okay. So that point in here is called the IP. So that is the inflection point. Right? So the first and second derivative test, so the first derivative can tell us in terms of increasing, decreasing, mins, maxes. Second derivative test tells us a bit about what's going on with the shape of the curve and where it's making that transition from concave up and concave down. Right? So let's go through another example of how all this works. So we'll go through the whole process. So we got f of x equals 4x cubed plus 3x squared minus 6x plus 1. So first derivative test, first derivative is going to be 12x squared factor out of 6. So 2x squared plus x minus 1. So with that, we want to set it equal to 0. Okay. So now the question is can we factor this? So now with that 2x, we know it's got to be an x and a 2x. It's a minus 1, and we only get one way. And because it's got to be a positive x, that'll make that the plus and that the minus. And we set it equal to 0. Okay. So now we're going to solve for x. So here we get that 2x minus 1 equals 0. Here we get x plus 1 equals 0. So here we're going to add 1. Add 1. Here we'll subtract 1. So 2x equals 1, and x equals 1. So this one we'll have to divide by 2, and x will be 1/2. Right? So my numbers of interest when I do my chart will be 1/2 and 1. Actually minus 1, the minus sign in there. Right? So now we'll make our chart. And so we're going to have minus 1, we're going to have 1/2. My factors were x plus 1, (2x minus 1). I did have a constant out front, and that number was 6, so put that in the chart. And then we want our derivative. Right? So we set up our chart, and now we ask, okay, what happens when, now first off, we are less than -1. So when we're less than -1, this will be negative. This will also be negative. My 6 is always positive. So again, a negative times a negative times a positive will be a positive. When I'm in between -1 and 1/2, well, again, the easy number to pick is 0. So this will be positive. This will be negative. The 6 is always positive. Positive times a negative times a positive is a negative. And lastly, when we're greater than 1/2, we will be positive across the board. Right? So here the slope is positive. This means increasing. Here it's negative, so that's decreasing. This is increasing. And so we go from positive to negative slope, that means this is a max. And then negative to positive, that means this would be a min. Okay? So that's everything in regards to my first order test. Again, the y points we can get by plugging in, and you can do that and get those later. So now we want to go to our second derivative test. Right? So our first derivative, we said was 12x squared plus 6x minus 6. 12x squared plus 6x minus 6. That was f prime. So my second derivative will be 24x plus 6. Okay. We take that derivative, we set it equal to 0. And solve for x, so we subtract 6. So 24x equals minus 6. Divide by the 24. And we get x will be -1/4. And again, we can set up our chart in terms of whether it's up or down. Right? And so we get -1/4. Okay. And my derivative was 24x plus 6. So 24x plus 6, my second derivative. So when we're less than -1/4, this will be negative, my derivative is negative. And when we're greater than -1/4, this is positive, this is positive. So this is concave down, this is concave up, and this is an IP. And again, in order to have an IP, in order to have the up and down, relative increasing, decreasing, there needs to be a sign change. One other example, and that would be, well, what happens if we have something that looks like this? X over x squared. Well, in order to do that one, well, first off, it's a fraction, so that means we're going to have to do it in terms of our quotient rule. So let's call f is x, g is x squared plus 1, f prime is 1, and g prime is 2x. So now if I plug that into my quotient rule, my derivative will be x squared plus 1 times the derivative of the top, which was 1, minus the top, which was x, times the 2x, all over the bottom term squared. Right? That's my derivative. Well, the next step would be to take this derivative and set it equal to 0. Right? Well, if I have one like this, right, the only time this can ever equal 0 would be if the top is 0. Right? So this can only be 0 when the top is 0. So I just need to look at the very top part. We got x squared plus 1 times 1 minus x times 2x. Okay. So now this time we're going to actually have to do this out. So this will be x squared plus 1. This will be a 2x squared. Okay. So x squared minus a 2x squared will be a minus x squared. Okay. Get that. We want to solve that for x. So let's take the x squared to the other side. So we get 1 equals x squared. And the opposite of squaring is to find the square root. So x will equal the square root of 1. Which means x will be plus or minus 1. Because again, square root, there are 2 answers. Right? So again, if you have one where you have a fraction and using quotient rule, like this, again, it can only be 0 if the top is 0. So now, if we look at this, and we now realize that the top becomes minus x squared plus 1. My bottom term, we said, was x squared plus 1 squared. This quantity squared. Okay. Okay. So now if I do my chart, okay, we're going to have 1 and -1. So let's call this -1. Let's call this 1. Okay. The top was a minus x squared. This is actually in my denominator. Okay. So we'll put that down there. Okay. Okay. And again, we want to look and see what's going on here in this case. And now we got our y prime. Okay. Well, let's first look at our denominator. Well, can this ever be 0? Well, it can never be 0 because x squared, a negative number squared is a positive number. A positive number squared is a positive number. And 0 squared is 0. And so that inside this parentheses will always be positive, which means when I square it, that will always be positive. So my denominator here each time will be positive. What's going on up top? Well, if I take a negative number and square it, it's going to be positive, but then we're going to make it into a negative. So this will be negative. If I'm in between 0 and 1, well, again, if you think about this being 0, then this is going to be a negative. Actually, this will be positive, sorry. And then when we're greater than 1, say 10, you get a negative, so this will be negative, right? So a negative divided by a positive is a negative. Positive divided by a positive is a positive. And then this is a negative. So this is decreasing, increasing, and decreasing. And so this is a min, and then this would be a max. But again, the key thing here for this one is when you do have, where you have a fraction, the only time the derivative can equal 0 is if the top part is equal to 0. Okay? So we only have to worry about the numerator when we're doing this whole first and second derivative test and determining if there's going to be that point of min or max. Okay? And with that, that will conclude this lesson on first and second derivative tests.